Hello everyone. Today we are going to write MATLAB program for Thomas algorithm method. So this Thomas algorithm method is generally used to solve tridiagonal matrix. So before that we'll discuss what is tridiagonal matrix. So tridiagonal matrix it is exactly similar as that of your diagonal matrix, but it contains one major diagonal, one sub-diagonal and one super diagonal. Okay, so you can take example of this matrix. So in this matrix, here A1, here this is your main diagonal, okay, A1, B1, C2, D2, E2, and here we can say that this diagonal element as a super diagonal element, okay, and this the diagonal which is just lies below the main diagonal. For that we can say that it is a sub diagonal element, and remaining all other elements are 0. So this type of matrix is known as a tridiagonal matrix, and to solve such a matrix, here we are going to use Thomas algorithm. Okay. So first we will discuss the analytical approach of Thomas algorithm method to solve simultaneous equations. So see here, suppose here this equation is given. Okay, four simultaneous equations are given. So what we'll do here, we'll represent this equation in terms of X is equal to B form. Okay, means in the form of matrix. So first we will represent coefficient matrix and then constant matrix. So write this equation in terms of coefficient matrix. Okay, so here we will get the coefficient matrix as a 1 2 0 0. Okay, then minus 1 1 2 0. Then next one is a 0 1 3 1, and next row is a 0 0 2 2. Okay, this is your variable matrix, unknown variable x1 x2 x3 x4, and this is your constant matrix which contains 4 1 7 8. Okay, then after that, this Thomas algorithm method is also one of the elimination approach. Okay, so as per elimination approach, we need to perform row operation to convert this coefficient matrix to the upper triangular form. Okay, so now what is upper triangular form? Below the major diagonal element, all the elements should be converted to zero. Okay, that is nothing but your upper triangular form. So here this matrix we need to convert to the upper triangular matrix by using row operation. So in short, in other word, we can say that here we need to convert this sub-diagonal element, which is minus 1, 1 to the 0 by performing the row operation, so that automatically this matrix will be converted as a upper triangular matrix. Okay, so just perform the row operation. So here what we'll do, we will first eliminate the first sub-diagonal element to the 0. So here we in the very first step we are removing the first lower diagonal element. Okay, so for that we require the row operation as the R1 plus R2. Okay, so after performing this operation R2 plus R1, this sub diagonal element, okay, first sub diagonal element minus 1 is converted to 0. Okay, simultaneously when we are performing this row operation, so it is applicable for entire column. Okay, so here you will get the change. Okay, so here you will get the next value as a 3 2 0, and for RHS also same operation you can perform R2 plus R1 as a 5. Now after that, after this matrix we need to convert here this element, okay, means this second sub-diagonal element to the 0, okay, which is just lies below this tree. So here we need to perform row operation. So we can take help of second row, okay, means your second pivot element, okay, or we can say that it is the second main diagonal element. So by using this second main diagonal element, we are going to convert this 1 to 0 by row operation. So for that what I'll do, I'll make this second diagonal element to 1 just for simplification purpose. So here you can convert this second diagonal element, okay, it is also known as a pivot element, to the 1 by dividing itself. Okay, so itself means here 3, so we need to divide row number 2 by 3. So here we will get the changes as a 0 1 2 by 3 0 5 by 3. Okay, now we can easily perform operation R3 minus R2. Okay, so just perform the operation R3 minus R2. So here it becomes 0 0. Here it is 7 by 3 1 16 by 3. Okay, so means here second sub diagonal element is converted to 0. Now in the next step we need to convert this third sub diagonal, okay, means these two values to the 0. So for that Again we will perform the row operation. Okay, so here we will take the help of third major diagonal element, okay, which is your 7 by 3. So just for simplification purpose we will convert it to the 1. So for that we will multiply the row number 3 by 3 by a 7. Okay, so automatically it becomes 1001 3 by 7 and it becomes 16 by 7. Now you can perform the operation as the R4 minus 2 times R3. Okay, so that this 2 will be converted to 0. So just perform this operation R4 minus 2 times R3. So now this third subdiagonal element is now converted to 0. Okay, and now this coefficient matrix will become upper triangular matrix. Okay, so now you can easily perform the backward substitution. Okay, so just by observation you will get the x4 value. X4 is equal to, you will get 24 by 7 into the 7 by 8, so it is x4 is 3. Once you get x3 you can find, sorry, once you get x4 you can find x3 value. Okay, once you get x3 and x4 you can find x2, okay, and so on x1. So like this we can find the x1, x2, x3, x4 value by using Thomas algorithm approach. Okay, so this is the analytical method. Now this logic now we are going to implement in the form of code. Okay, so here I have already written the code for Thomas algorithm method. So here I'll explain you the meaning of this code. Okay, how to write the code, how to implement this logic. Okay, what are the logic for that particular program. Okay, we have discussed. So see here, so what I'll do, I'll copy this code in the paint. Okay, so that I'll explain you each and everything, each and every line. So see here, here I have copied this portion. Okay, up to this portion, up to this part copied. Okay, so I'll explain you how to implement this logic. So here, first thing we need to, here it is given as a n variable. Okay, and here we need to enter the number of equations. Okay, so before, suppose here to solve this simultaneous equation. Okay, first thing we need to identify the number of unknown variable in this equation. Okay, suppose in this equation four unknown variables are there, so that means x1, x2, x3, x4. So that unknown variables we need to input in the code. Okay, so for that we have considered the variable n is equal to, okay, number of equations. So we can write the this n variable, okay, by using input command. So n is equal to input and just give the command, enter the number of equations. So this line will give you the number of equations. Okay, then after that we need to represent this equation in the form of matrix. Okay, so which matrix? X is equal to B form. So here we need to write this. This is your coefficient matrix and this is your constant matrix. So we need to write A matrix as well as B matrix. Okay, so for that we are writing the logic in the form of code. Okay, and the logic is for I is equal to 1 as to n, and under that for j is equal to 1 as to n. Okay, so here what is this looping, purpose of this looping? Okay, the purpose of this for loop is just to write the matrix. Okay, by the uh, just write, used to write the matrix, coefficient matrix as well as constant matrix. Okay, so what is I signifies and what j signifies? So in this case we are considering I as a row number. Okay, we are considering I is just for designating row number and j is considered for designating column number. Okay, so here we are going to write this matrix. Okay, if you look at the example, we are going to write this equation in the form of matrix by row wise. Okay, first we will write first row, then second row, then third row, fourth row. Same logic we are implementing here. Okay, by using looping. So for I is equal to 1 as to n, means when your row number 1 is there, that time we are going to write first row value. Okay, and how to write this value? So here we are taking one more j loop, j. Okay, so which signifies your column. It is also we are taking from 1 to n, means we, for first row we have to write 1 to n number of column. Okay, means under I loop we have defined j loop. Okay, means when your I is equal to 1, okay, means we are writing first row. The meaning of this first line is I is equal to 1 as to 1, means we are writing first row. Okay, so in the first row we are using j is equal to 1 as to n. Okay, means in the first row we are writing all the elements column wise. Okay, so column wise means here we are writing first value in the first column, then second in the first column, then 0 in the third column, four, then 0 in the fourth column. Okay, for the first row. So see here, this is the logic. So when I is equal to 1, that time j is equal to 1 means we are writing I a of ij, okay, means a matrix which contain I row and j column, okay. That time we are inputting the value of, or we are writing the coefficient matrix say. When I is equal to 1 means first row is there, that time j we are taking as a 1, so we are writing first element a as a is equal to 1 1, okay, means suppose for example we have written 1, okay, first row first column. So this row are signified by I variable, okay, and this column are signified by the j variable, okay. So a of I j, when I is equal to 1, j is equal to 1, that time I am writing first element as a 1, okay. Same way now under I loop we have defined j loop. So first j will be completed, then we are going for I is equal to 2, then I is equal to 3, so on, okay. So first complete this j loop. So here I remains 1, okay, and j now it becomes 2 for the second case. So here we can write a of 1 comma 2. 1 comma 2 means first row second column. So here as look at the example, here first row second column is here we are writing two value, okay. So that value we have written first row second column. Same way now suppose if you are taken number of equation 4, so we have to write values from 4 row and 4 column, okay. So here now j becomes 3. So for that time we need to write the value of a of 1 comma 3 means first row third column means 0 will be input, okay, will be given. Then next j is equal to 1 4, okay. That time we need to write value of a matrix as a I comma j means I is 1 and now j is 4. So a of 1 comma 4 means first row fourth column. So it is again 0. So first row is completed. J is equal to 1 as to 4 because here in this particular example we have taken number of equation is equal to 4. So that's why we need to consider 4 rows and 4 columns. So here number of columns are completed. Okay. So means we have written first row. Now this loop will be j loop will be terminated. Okay. Now still we are in I loop. Okay. And here at the same time we are writing constant matrix also. And here what is the value of I is equal to 1 means we are writing first row. So we are writing value of b1, okay, and here we are writing first constant matrix. So b1 is nothing but your 4. Now first row is written. Same way now the loop will continue. Now I becomes 2. So means we are writing second row. For second row also we are taking j is equal to 1 as 2 n. Means in the second row we are writing all the elements. Okay, now we look at this all the elements. This element belongs to the each column 1, 2, 3, 4 column. Okay, so here we are writing when row number 2 is there, I is equal to, that time we are writing j, we are considering column 1 to 4, okay, and we are writing of I comma j, which we are writing now coefficient matrix, okay. In coefficient matrix I is now 2 and j is the 1. So 2 comma 1 means minus 1 will be written. Then second j becomes 2. So a of 2 comma 2 means second element 1 is written, okay. Then j becomes 3. Third column will be considered means second row third column. So it is second row third column means here we are writing two value. Same way j now column becomes 4. So a of second row 4 column. So it is 0. Okay. So here second row is completed for the coefficient matrix, okay. So once the 4 columns are completed, so the j loop will be terminated, okay. Now you can go for next logic as a b of I. So here row number 2 is selected, so that we can write b2 value as a 1. Now again loop will be continued for the third row. Now I become 3. So now we are writing third column, okay, and in the sorry in third row we are writing all the values as a 0 1 3 1 column wise. So here we are writing logic for j is equal to 1 as 2. So it becomes I of 3 comma 1. 3 comma 1 means 0. I of 3 comma 2 because j becomes 2. Here 1. 3 comma 3 means 3. 3 comma 4 means 1. Okay. Now again j loop will be terminated. We can write the b value b3 here. Again, I now becomes 4. So we can write the fourth row as a 4 1, 4 2, 4 3, 4 4. Okay. And after this J loop will be terminated and you can write the B4 value as a 8. Okay. Now once I is equal to 1 as to 4. Okay. Fourth row is completed. There is no fifth row. So automatically this loop will be terminated, and by using this condition, okay, by using this for loop, you are defining your coefficient matrix as well as constant matrix. The purpose of this for loop in the program is to define the matrix, okay. There is alternative way, you can directly input a matrix and b matrix, okay, in the program, or you can define that a matrix and b matrix in the generalized form, okay, by using rows and columns. There are number of approaches you can consider. Either you can directly enter this value in the square bracket, okay, in your code, or you can define by using I loop and by using for loop, okay. So the purpose of this looping is to just define the coefficient matrix. Okay, if you look at the example, so this matrix coefficient matrix A and B is defined by using that particular loop. Now next logic in the code. So here in this particular program, what is the, suppose let's take an example. Okay, I'll tell you, we'll discuss one example. uh, so along with this example I'll explain you the code. Okay, so suppose same this problem we need to solve with the help of Thomas algorithm. First we will represent in terms of matrix form. So this coefficient matrix is written and this is constant matrix is written. Okay? So now what we have to do after representing matrix form, we need to, yes, convert the lower diagonal element to the 0. Okay, so here lower diagonal element is a 2 2. Okay, so this lower diagonal element we can convert to 0. So first we will convert this 2 to 0. Okay, so this 2 value is now converted to 0 by row operation. So which row operation we require? We need to perform R2 minus 2 times R1. Okay, so we need to perform operation second row minus 2 times first row. Okay, so this logic we are going to write here in the form of code. Okay, so now guys, here we need to perform operation on second row as well as third row. See here, because second sub diagonal means sub diagonal element means lower diagonal element belongs to the second row, and third sub here another sub diagonal element or lower diagonal belongs to the third row. Okay, means we need whatever the row operations are there that we need to perform on second row and third row. So that's why here what I'll do, I'll write the logic in the form of loop for I is equal to 2s to n. Okay, means we need to consider the row number 2 up to the n, up to the n number of equations. Okay, so in this case suppose we have three equations. Okay, so we need to consider second row as well as third row. Okay, while doing the row operation. So here when I is equal to 2s to n, the meaning of this, we need to firstly we need to consider second row operation, then we need to perform operation on third row. Okay, so two iterations will be there on second row and third row. And what is the purpose of this entire loop? Just to make your lower diagonal element to the 0. So automatically this coefficient matrix becomes 0. Okay, so what is the purpose of this looping? We are converting this minus 1, then this 1 and this 2, which are your sub diagonal element, to the 0. Okay, so now if you consider this example. Okay, suppose if you consider this example, so for this example now we are performing operation on second row as well as third row. Okay, so let's see the logic. When row number 2 is there. Okay, so initially we, when I is equal to 2, in the first iteration we need to consider I is equal to 2. That time we are selecting row number 2, and here we have taken one variable as a fact. Okay, and what is the purpose of this fact, guys? Here we need to perform operation R2 minus 2 times R1. Okay, so we are multiplying the first row by 2. Okay, so here what we are going to do, just for doing that row operation, we are identifying the multiplying factor. Okay, so which multiplying factor is consider for the row 1. Okay, so that we can perform operation R2 minus 2 times R1. So that multiplying factor we are considering, and for that multiplying factor here we have defined the notation as a fact. Okay, you can take any notation. Then here we need to identify that multiplying factor. Okay, so here what is that multiplying factor? Multiplying factor is a 2. Okay, so for this case it is a 2 because we need to perform operation R2 minus 2 times R1. So we have to multiply first row by 2, so it becomes 2 4 0 6. Okay, so then we can perform easily perform operation R2 minus R1. Okay, so first multiply this row 1 by 2, so this coefficient becomes equal and you can easily perform the subtraction. Okay, so what we are going to, we are first finding the multiplying factor. And how to find this multiplying factor? We can find this multiplying factor, okay, by the logic. So logic is given coefficient matrix A. Okay, so for that A of I comma I minus 1 upon A of I minus 1 I minus 1. So here I'm just elaborating this thing. Okay, so here we have considered I is equal to 2. So A of I means A of 2, I minus 1 means 2 minus 1, A of 1. Okay, so then it is divided by A of I minus 1. I is 2, so A of 2 minus 1 means 1, A of 2 minus 1 will become 1. So in short, this multiplying factor is nothing but the division of A of 2 comma 1 upon A of 1 comma 1. Okay, just look at this example. So A of 2 comma 1 is second row first column. What is the element? 2. Okay, it is divided by, yes, it is divided by A of 1 comma 1 is first row first column. Okay, so A of first row first column is 1. So 2 is now divided by 1. Okay, so in short we will get the multiplying factor as a 2. Okay, means we can say that fact value, okay, fact is nothing but 2. Okay, and the purpose of this fact, it is just to find the coefficient of lower diagonal element for row operation. What is the purpose of this fact? Just to find the coefficient of lower diagonal for row operation. So coefficient means we can say that it is a multiplying factor. Okay, so here the purpose of this fact to just find the multiplying factor. Now what we are going to do, we are multiplying, okay, this fact, this 2 to the first row. Here if you look at this example, what we have to do, we need to perform operation R2 minus 2 times R1. So here we are multiplying this 2 to the first row. So we are multiplying this to the entire elements of the first row. So what are the changes here? So 2 into 1. So here you will get 2. Then 2 into 2. Here you will get 4. 2 into 0 0, and here you get 2 into 3 6. Okay. So your coefficient of first row and second row becomes similar, and you can easily perform row operation as a R2 minus R1. Okay. And here, so what we are going to do? We are now multiplying this fact, okay, or this multiplying factor to the first row. Okay, and how to multiply it? So when we are multiplying this 2 to the entire row, obviously all the elements are changes. So first element becomes 2, second element becomes 4, it becomes 0, and this becomes 6. Okay, so in short we need to perform operation on first column, second column, third column. Okay, so this multiplication we are going to write in terms of looping, and for that I am considering column. So j variable represents column. So we need to write from the first column to the n number of columns. In our case n is 3, so we need to write from first column to the third column. Okay, and what we are to do, we need to multiply this factor to the first row. So for that I'll consider the first row. So what is the first row? A of I minus 1 comma j. Okay, a of I minus, so I is initially 2. Okay, and j is 1. So we are writing a of here 2 comma 1. Okay, and here what is the logic behind it? Here a of I minus 1 comma j into factor. Okay, so here what I minus 1 means, 2 minus 1, it becomes 1. Okay, and j is 1 initially. So a of 1 comma 1, a of 1 comma 1 means here in this example it is 1. So for that we are multiplying fact. What is fact? 2. 1 into 2, 2. So here it becomes 2. Okay, here I'll show you. Okay, so here it becomes 2. Okay, so just multiply here. So first element becomes 2. Then here it becomes 2. Then j becomes 2, because we are considering column from first to third. Okay, so now we need to select second column. So that time what are the changes? A of I minus 1. So I is 2 means first row second column. First row second column means second value in the first row. Here this is the value. So now on this 2, for this 2 we are multiplying by the multiplying factor. So 2 into 2, it becomes 4. Okay, so it becomes 4. Second element it changes to 4. Then same way now we are selecting the third column. J is equal to 3. So here what are the changes? I minus 1 means 2. Sorry, 2 minus 1 becomes 1, and J is 3. So 1 comma 3. A of 1 comma 3. A of 1 comma 3 means this is the 0. We are multiplying 0 by 2, so it is remains as the 0. So first row it changes to 40. Okay, so here instead of 120 we can write 240. Okay, same changes are applicable for constant matrix also. Okay, for constant matrix here what are the changes? Now after third row, okay, there is no after fourth column there is no fourth column, so this j loop will be terminated, and we are performing operation on b. So what is that operation? B of I minus 1. I is 2. So in short 2 minus 1 means we are taking b1. So we are multiplying that b1 by this multiplying factor. So what is that multiplying factor? 2. So we are multiplying b1 by 2. So what is b1 in this case? b1 is a 3. We are multiplying it by 2, so it becomes 6. Okay, so we can write here it as a 6. It changes to 6. Okay, so now we have multiplied this 2 to the r1. Okay, so now coefficient of row number 2, okay, and coefficient of row number 1 is same. Now we can easily perform operation r2 minus 2 times r1. Perform that operation r2 minus r1. Okay, and that logic also we are going to write in the form 4 as here. We are for that also, when we are performing row 2 minus row 1 operation, that time each element in the row 2 will be changes. See here, when we are performing row 2 minus row 1 operation, that time each element in the row 2 is 0, okay, minus 1 1 minus 2, these elements are changed, okay. So these element belongs to the separate column, first column, second column, third column. So we can perform the operation column wise here, okay. So on second row, okay. So what is the logic here? Row remains same, row is 2 because we are performing operation on row number 2, okay. So just perform the operation R2 minus R1. Okay, so we are considering J. Okay, so when column number 1 is selected, A of ij, I is now 2, J is 1. A of 2 comma 1 minus A of I minus 1, J. I minus 1 means A of 1 comma 1 means first row. So in short, what is the meaning of this? See here, it's here. When j is equal to 1 means A of 2 comma 1 minus A of 1 comma 1. Okay. So in short, we need to perform row 2 minus row 1 operation. So what are the changes? A of 2 comma 1 means here 2 will be there. Okay. And what is the first element? Again 2, because we have multiplied 2 to the R1. So 2 minus 2, it becomes 0. Okay. So here first element changes to 0. Then again we need to go for j is equal to 2. So when j is equal to 2, what are the changes? A of 2 comma 2 minus A of 1 comma 2. So what is A of 2 comma 2? A of 2 comma 2 means here it is your second element. What is that? 3. Okay, 3 minus here it is 4 value. So 3 minus 4, it becomes minus 1. Okay, so 3 minus 4, it becomes minus 1. Same way when j is equal to 3 means see the logic. A of 2 comma 3 minus A of 1 comma 3. 2 comma 3 means second row, third column. Second row, third column means which element? This 1. So 1 minus 0, it remains 1. Okay, so we'll write here 1 minus 0, it remains 1. Same way, whatever the logic we are performing on coefficient matrix, it is applicable for constant matrix also, because here after third column there is no fourth column, so j loop will be terminated, and here we are going to perform operation on yes b2. So b2 is equal to b2 minus b1. Okay, so b2 minus b1. So in b2, yes, what is the value? b2 it is 4 and b1 it is 6. Okay, so 4 minus 6, it becomes minus 2. Okay, so here we'll write 4 minus 6 as a minus 2. So this is when I is equal to 2. Okay, so means we have converted here the first diagonal element, lower diagonal element. Okay, means we have converted these 2 to the 0. Now same logic will be performed on the third row. Okay, in third row these 2 will be converted to 0. Okay, by the next operation, and for that same logic will be this code will be continued. Now here I becomes 3. Okay, I becomes 3 means we are considering row number 3. So for row number 3, we need to find the multiplying factor. Okay, and which multiplying factor you require for this case? See here, multiplying factor is again same here, 2. Okay, so we are multiplying uh, uh, 2 to the second row, so that coefficient of row number 2 and row number 3 becomes same. See here your lower diagonal element is a 2. Okay, and this 2 we need to convert to 0. So for that we need to perform operation row 3 plus row 2, but here coefficient of row number 2 is a minus 1. Okay, so we need to make it equal to the row number 3. So in row number 3 there is a coefficient 2, so we will multiply that coefficient to the second row, so it becomes minus 2. So we can easily perform operation R3 plus R2. Okay, so first we will find the here multiplying factor, same logic will be there. Okay, multiplying factor is now just put the value of I is equal to 3 here. So a of 3 comma 2 upon a of 2 comma 2. Okay, so you will get factor here multiplying factor as a 2. Okay, and same logic will be continued, and here the second lower diagonal element is converted to 0. Okay, and the purpose of this looping is just to convert the now we are at this stage. Okay, so all the lower diagonal element means this element and this element is converted to 0. Okay, now after that we will find the values of unknown variable, okay, which are z, y, x by using logic. Okay, so this is the logic for making the lower diagonal element to the 0. Now next, this logic is to yes convert all the major diagonal element to the 1. See here luckily in this example all the diagonal element are becomes 1. Suppose if there are changes, if your third diagonal element is suppose here minus 5, okay, and here minus 2. So just for making calculation simpler form, we are going to do, we are making this diagonal element to the 1. Okay, in this particular example all the values are 1 only. Okay, 1 minus 1. Suppose if while doing calculation, suppose the third major diagonal element is suppose minus 2. Okay, So we need to perform operation with a minus 2 times z is equal to minus 3 while backward substitution. So just for making simpler calculation, what I'll do, we are going to make a diagonal element to the 1. And how we are going to make it to the 1? Suppose here minus 2 is there, so we are dividing this third diagonal element by itself. Okay, so when we are defining dividing minus 2 by minus 2 only, it becomes 1. Okay, so that logic is given here. Okay, for I is equal to 1 as 2, and that time I am considering diagonal element a of I, means a of I means a of 1 comma 1, means this is the first diagonal element is considered. And when we are dividing this first row, okay, by this diagonal element itself, that time this first value becomes 0. Oh, sorry, it becomes 1. Okay, luckily it is 1, so 1 by 1 it remains 1. Okay, so the purpose of this looping is to just make your all major diagonal element to the 1. Okay, so here we are converting all the diagonal element to the 1. Okay, now next thing, we are going to find the unknown variable, okay, which are z y x in our example. So by using backward substitution, okay, so just look at this stage here. We can say that z is equal to 3 just by looking at this. Okay, so this logic we are going to write as a x of n. So in this case, n is our 3. Okay, so can we say that x n means we are finding the value of x3. X3 means in our case it is z. Okay, so z value directly we are getting from this logic here just by backward substitution. Minus z is equal to minus 3. So we can say that z is equal to 3 just by observation. So that value we are that logic we are writing here. B of n. B of n means b3. What is b3 in this case? In our case, b3 is your minus 3. Okay, it is now divided by a of n. Okay, what is a of n means in our case n is 3. So a of third row, third column. So a of 3 3. A of 3 3 is nothing but in this case it is minus 1. So minus 3 is divided by minus 1. So we directly will get the value of x of 3, which is nothing but z. Okay, so z is equal to 3. So this is my logic. Okay, now by using this z, we are going to find the values of s, y, and x. Okay, so for that I am writing now, to find y we need to consider second row, to find x we need to consider first row. Okay, so what we are going to do here, we are taking this logic. Okay, we are considering looping from I is equal to n minus 1 as 2 minus 1 as to 1, means this is the logic from for backward substitution, because we need to move from, yes, third row, second row, first row. Okay, so third row we have already calculated this unknown variable z. Now we are focusing on y and x. So we need to select first second row, then first row. So that's why we are writing this logic in terms of I is equal to n minus 1. So n is 3. So 3 minus 1 means 2. Okay, so we need to perform first operation on second row, then first row. Okay, so when your second row is there, okay, when second row is considered, that time the loop will be continued. So in that same case, j loop is defined. So j is equal to I plus 1 as to n. Okay, so I plus, now I is now in this case 2, means first row is considered, and j is equal to I plus 1. So I is now 2. 2 plus 1 3. 3 as to n is equal to 3. So we need to consider third column. Okay, so j, in short, we will get the j value is equal to 3. We will substitute this I value and j value in x of I. So x of I here second row is there, so I is equal to 2, x2. Then b of I, so I is 2 means b2 minus xj. What is the value of j? I plus 1. I plus 1 means 2 plus 1 3. So we substitute x3 into a of ij. I is 2, j is 3. A of 2 comma 3, and this whole term is divided by a of I is second row. Okay, means we are defining second row, second column. So what is that logic? B2. So here what is B2 in our case? B2 means minus 2. So we will consider minus 2. Okay, then it is subtracted by x3. X3 means in this case it is z. Okay, so what is the value of z? We have calculated z is equal to 3. Okay, so we will consider z is equal to 3. So minus 2 minus 3. Okay, then into a of 2 comma 3. A of 2 comma 3 means second row, third column. What is second row, third column? 1. So in short, y. Okay, so we are multiplying the here y. So you will get, okay, and this whole term is divided by the a of 2 comma 2. What is a of 2 comma 2? It is nothing but the your coefficient of, sorry, coefficient of y. Okay, so you are getting coefficient of y as a -1. Okay, see here I'll show you that logic in the print itself. Okay, so suppose this is print. See here, what is that logic? Just look at this code. So v2. Okay, I'll just copy this. Uh, okay, so v2 minus x3. Okay, so this entire code I'll copy, or I'll write there. Uh, x2 is equal to, yes, what is that, v2 minus x of 3, okay, into what is that logic, a of 2 comma 3, okay, and now whole this term is divided by a of 2 comma 2, okay, and so what is b2 in this our case, guys? B2 is nothing but in this case it is minus 2, okay, so we'll write here minus 2 as a b2, okay, then it is subtracted by, yes, x3 is nothing but your z value, and it is multiplied a of 2 comma 3. A of 2 comma 3 means second row it is 1, okay, so we are multiplying it by 1, okay, and this whole term is now divided by the coefficient of, yes, coefficient of y. A of 2 comma 2 means it is nothing but coefficient of y, it is minus 1, okay, so it is divided by minus 1, so you will get the directly y value, okay, so x of 2 means it is equal to, directly we are getting y value, okay, and this is the logic. So x of 2 is nothing but y here, and y is equal to, we will get this equation, minus 2 minus z into 1 upon minus 1. So what is the value of z? Z is equal to 3, okay, so directly we will get the value of y from this calculation. Okay, now this loop will be once you get x2, x2 is nothing but y in this case, okay, so once this loop is completed you can print this value of x2, okay, by using f command. Now loop will be continued, okay, and here now initially row number 2 is selected, now you can select row number 1, okay, in the row when you are considering row number 1 you are finding the value of x1, and what is x1 in this case? X1 is nothing but your x variable, first variable, okay, and same loop will be, logic will be continued, okay, and this is the logic, and here we, at the end we will get x1 value. Like this you can find the value of unknown variable x1 and x2, x3, okay. So this code is written for Thomas algorithm method, okay. I'll show you execution of code, okay, so for that you can use the online platform. So here already uh, you can use the Octave online solver, okay. Suppose Octave online solver, okay, just select it, and here click here Octave online solver. You need to just do the login with your Gmail, okay. Here I have already done the Gmail login. Here this is your programming window, and here you will get, here it is the console, here you will get the output, okay. So first I'll make the file, and the file says suppose it is the Thomas, okay, algorithm, okay, and for that just save this file, okay. So Thomas algorithm, just click here, so this file will be open, and just whatever the code is there, just paste your code here, okay, and save this file. Now the code is written, okay. You can write the code alternately somewhere in notepad or wordpad, okay, just copy that code and paste here on this programming window, and now you need to execute this code, okay. So I'll just execute this code, and the code will be run, okay. So we'll take example. So let's take here, suppose we have the example. Okay, suppose we have this example, x1 plus 2x2 is equal to 4, okay, four equations are given, okay, so we'll put these values in the form of your console. So how many equations are there in this example? So total four equations are there, okay, so we'll write n is equal to 4, okay, enter. Now it is asking me the enter the coefficient matrix, okay. So now one more thing you need to remember, we have defined the coefficient matrix row wise, okay. If you look at this logic, we have defined the coefficient matrix row wise, so we need to enter this value row wise, means 1 2 0 0, okay, like this we need to enter. So let's see here, what is the first value, first coefficient 1, okay, enter. So here 1 comma 1 is written. Next we need to define 1 comma 2. Okay. So define 1 comma 2 is here 2. Next value it is 0 0. Okay, so just input third element as a 0, next element as a 0. Now it is asking me the coefficient matrix. Okay, so it is for the first row. Okay, so what is the value of b1 in the first row? 4. So enter 4. Same way, now we are going to write second row. In the second row, what are the value? Minus 1 1 2 0. Okay, so just input that value, minus 1, then 1, then 2, and then 0. Okay, what is the value of RHS here? 1. So just input that value, 1. Next, third row 0 1 3 1. Okay, so just input 0 1 3 1. Okay, what is RHS? RHS equal to 7. So just input 7. Next, 0 0 2 2 8. Okay, so just input 0 0 2 2. Okay, and what is the coefficient of p? 8. Okay, and here you will get the value of x1 x2 x3 x4. Okay, and these are the unknown variables here in this example, x1 x2 x3 x4. So these unknown variables are now calculated with the help of this coding. Okay, this is the code for Thomas algorithm method. Okay, so this is about your Thomas algorithm method. Okay, thank you.